Algebra 2, Lesson 22, Uniform Motion Problems with Equal Distances and Similar Triangles and Proportions. We're going to start off with Similar Triangles and Proportions because that can be done much faster. So, starting in Practice B, we need to use proportions to solve for x and y. What we're going to do here is set a proportion using our known sides. The only two sides we know of with whole numbers is 5 to 6. So that's our first proportion. 5 is to 6. Now we have to figure out what is in the same ratio as 5 to 6. Now if you look at the similar triangle tick marks here, you'll see that this triangle is upside down, or this one's upside down, but they're not perfectly oriented because the similar angles are here and here instead of here and here. So the sides that are similar in this case would be x is to 7 and y is to 9. So we'll do two proportions. 5 is to 6 as x is to 7 and as y is to 9. From here, hold on, let's fix our focus. From here, we just cross multiply each equation to solve. This first one, when we cross multiply, we would get 6x equals 35. And to solve that, we just divide each side by 6. So x equals 35 over 6. So that one's done. Pretty easy. The next one, cross multiply again, we get 6y equals 45. Divide each side by 6 again. And here we'll actually see that 45 and 6 are both divisible by 3. So we divide 6 by 3, we get 2. 45 we divide by 3, we get 15. So y is going to be 15 over 2. That's that. It's a little bit faster than a scale factor, or if proportions are hard for you, maybe the scale factor is easier. But proportions are very, very useful. Now, to uniform motion problems with equal distances. Hold on, what's going on with my focus? There we go. So this problem tells us Elvira made a trip on Tuesday and David made the same trip on Wednesday. So we'll just call her E and we'll call him D. E traveled at 14 miles per hour. D traveled at 21 miles per hour. So his time was 3 hours less than E's. How far did they travel? So we're going to have to write some unknowns using subscripts. The first one is going to be the distance of E and the distance of D. We're trying to figure out what their distances are. Now they tell you to start by using a distance diagram. Something like this. The diagram is just a start point and a finish point. And in this problem, since it says they made the same trip on different days, they're traveling the same distance. So what we learned about their distances is that distance of E is equal to distance of D. Now this is going to be the basis for setting up our problem. Now the equation that you should memorize for these problems is the distance rate time problem, which is distance is equal to, that's a B. Distance is equal to rate times time. So if distance is equal to rate times time, instead of writing the distance of E, I can substitute her distance for her rate and time. So I'll take this equation and I'll rewrite it as rate of E times time of E. All right, and then same thing with David, or distance of D. I'll replace that with rate of D times time of D. Now I've got a base equation that I can start substituting and solving into. So right now, all of our uniform motion problems are going to take this form. Rate of subscript A, rate and times time of the first person is equal to the rate and time of the second person. So now we go back to our problem and start plugging in information we know. They tell us that the rate of E, or her speed, was 14 miles an hour. And the rate of David is 21. So instead of writing R sub E, I can write 14 times T sub E. Oops. And then instead of writing the rate of D, I can put his rate, which is 21, times his time. Now the last thing they tell us is that his time, so David's time, was 3 hours less than E's. So now we have to write an equation of that. The best way that I've found to do these is write them as equal and then fix the statement. So we know that time of E is not equal to time of D. So how do we make that true? Well, if his time is 3 hours less, what do I have to do to his time to make it equal to hers? I either have to add 3 to his, or I have to subtract 3 from hers. I'm going to go ahead and add 3 to his time, so that would make his time that's 3 hours shorter equal to her time, which is longer. Now, once I've got this information, I can substitute this quantity for time of E. So, again, I'm going to rewrite this top equation. It's going to become 14 times TD plus 3 is equal to 21 TD, or T sub D. Now I've got an equation with one unknown. I can substitute and solve. 14 times T sub D gives me 14 T sub D, and then 14 times 3 gives me 42. That equals 21 T sub D. So from here, I'm going to move all the unknowns to the same side, subtract 14 T sub D. Those cancel. That becomes 7 T sub D. And we've got 42 equals 7 T sub D. Divide by 7. And 7 goes into 42 6 times. So time of David is equal to 6. From here, if I've got David's time and I've got his rate of 21, I can figure out his distance. All I have to do is take 21 times 6, and I get his distance of 126 miles. And that's that.